Hello, Gabriel. You're on time, dude. Got a couple minutes before we get started. So you definitely want to resize your screens, Gabe, and get ready for we're reviewing a problem. Excuse me, from last Tuesday. So get ready to review the problem. You're gonna set up a Google Doc. So, who's coming in the room now? This is Miss Richardson. Welcome to class. Uh,
Good
Pretty
morning.
much. Hello, hello. Okay, so we're just waiting for everybody else to get here. After that, it's 8 minutes is up. They will be considered late or absent. Um, Someone else is coming in. Who is this? Lisa Brown is here. Lisa, you already know the drill. So everybody should be logged into Edsby and ready to get started. The Facebook drawing is out there. Just making sure I put it out there to be known. You could win $100, or but I don't know who will win. So you could win $100, whoever you are. It depends on which teacher you said told you about the drawing. So definitely take advantage of it. The information is there on the flyer inside of Edsby. So take a couple of moments. Today I want everybody to find the print screen button on their keyboard. That is how you're going to copy the simulation for today, because the simulation for today doesn't have a screenshot feature. So when you hit the print screen button, you only press it once, I think, on your keyboard. It takes it to the clipboard, and you could paste it into your Google Doc. The first set up your Google Doc. So basically, print screenshot will look like this here on my screen, but that's because I have two screens that I'm using. So get ready to do that and test out how print screen works. And then once we get the image, we're going to crop the image and make it just where we have a simulation. So this is the simulation we're going to be using in a moment. I'm going to put in the chat the simulation. I want to see this in advance because we're not using basic HTML today. We're using something a little bit higher. I think it's Java based, and it may work, it may not work, but I need to make sure. So I'm going to put this link in the chat, and you can definitely click on that and get yourself ready. We used a simulation in the past, but now we're going further into what charge is. And you guys are robotics students, so you got to understand first what a robot is powered off of. All right. One moment, please. Okay. So did everybody get a chance to click on the link? Let's see who's in the room. Uh,
Is the link in the chat?
yes, it's in the chat. Do you need to post it again?
Yeah, I need somebody to say something so I can tap it.
Okay. I'm gonna put it back in there because I guess when you came in, you might not have seen it. Okay, there it is again. So you want to click on that and try to recreate this simulation that's on the screen. You got about 4 more minutes. Dajay, okay, where was she at in SAT prep? Hello, Miss Moore. What happened to you in SAT prep today?
My computer broke.
Uh-oh, you on your phone?
Yeah,
Oh goodness.
but I took my computer to the shop.
Okay, they're gonna
Yeah,
fix it,
so
or
yeah, they charging me 150.
yikes. Okay, so I'm gonna put in the chat a link, Dajay. I want you to see if you tell me if you can access it. This is going to
Okay,
be the link you use for the simulation for today's work. And
okay.
there you go. So a few more minutes, just getting people a chance to get set up. I'll tell you what you should do on the simulation, and then you'll know that you have to have it set up that way so you take your print screen or your snapshot of this, you can put it in the document correctly. You also should be setting up a Google Doc. So if you're not sure how to do that, you can be on a phone, you can be on a computer, but you just log into your Google Apps using your Gmail account. And then after that, you can click on your Google Apps and go to Doc. So that's to start a whole new Google document. All right, I'm gonna do a blank doc, and that's how you establish a whole new document. Now we got to do some things to it. We have to name it, right? And the name on it is going to be "Do Now." Waiting for it to fully load. There it goes. So "Do Now," like that, and you're going to type today's date. That's the 29th of, my goodness, September is flying away. So after you do that, you got to, of course, put your header. So your name, like I put mine here, the date, 9th, and it is 2020. Period 3, or third period. And you guys are intro to engineering students, or robotic students, basically. All right, so you should have this much typed up so you can really get started. And then grab the problem and figure out who knows the title in a moment. How much time we got left? So about 2 more minutes.
What's today?
Today is the 29th. So in a couple minutes, we're going to do our norms. When that timer expires, it's time to make sure your microphone's working because that's participation. You at least be able to speak. Because I'm going to ask each of you to recite one of the particular norms. Okay, this is Lee Carter coming in the room. Let me
Can you
check.
Mr. Tyler?
Yes.
Can you put the do now and the like the
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 question.
yeah, the questions up in the chat so I can copy and paste because I can't do it from SB on my phone.
Okay, so leave me a minute. Let me do that for you. Grab it from Esby for you and put it in the chat. Okay, come over here. Let's take a look at this. All right, those are your 2 questions. The one we're doing in class and the one you have to do on your own outside of class. All right, now, we're only going to make a simulation graph, everybody, for one of these problems, our synchronous problem. When we get to the asynchronous problem, you don't need to make another simulation. You just do the same calculations I'm going to do with you. Now, there's points for somebody if they can give the initial steps to solving this in the chat. This is my way of seeing who actually took notes. So you can go to your Google Drive and see if you can find this original problem and put the initial steps to solving this problem in the chat. If you got that, that's 20 points towards your score. All right, so norms. So you're done with the norms. I'm gonna see if anybody has it, or I'm just gonna, do it myself. So put in the chat if you think you know what you should do with this problem. Remember, we did this problem Tuesday. So if you're in class, you type something up, you might have notes on it. You just got to go find them. All right, let's go down the list so we can make sure people are in their seats and ready. I'm calling your name and we need you to just recite the norm that I tell you to. So let's start first on the list. Ms. Richardson, can you read number 1? Ooh, Lisa, I think she took it. We're going to come back to that.
No one has the right to hurt another person.
Thank you. Dajay, can you read number 2?
Education and classroom are always secret.
Thank you. Gabriel, number 3.
We will never behave in a way that shows our school our family.
Thank you, sir. Mr. Carter, number 4.
At Excel Academy Southwest, a student is always a lady or gentleman.
Thank you, sir. Number 5, Lisa Brown.
We take pride in the Excel Academy in Southwest.
Awesome. We got 5 more to go, everyone. This is to wake us up and get us ready to start learning. So, Miss Richardson, number 1.
We respect the opinions of others.
Thank you. Miss Moore, number 2.
We respect the culture of the classroom.
Awesome. Gabriel, number 3. Uh-oh. Uh, can he get his mic on? Gabriel, you there?
We are attentive and participate.
All right, sir. Yes, we are. There you go. Lee Carter, can you read number 4? Uh-oh, did I lose him? Mr. Carter, are you there? All right. Well, Lisa, can you read number 4 then?
We have high expectations of ourselves, our peers, and our teachers.
And I'll take care of the last one. We are here to focus on preparing ourselves for post-secondary endeavors. Now, here's another participation point moment to see if you're paying attention. Who can write in the chat what are 3 of these post-secondary endeavors that you could always focus on? In terms of number 5, what are 3 post-secondary endeavors? So type it in the chat. What do you think they may be? And Lisa gets the points because that is where I'm starting at with the first problem. So I'm going to take what Lisa has and clean it up in my Google Doc. You guys should do the same. She's given some starting data. So I'll come to my Google Doc. And Lisa got all of them. Yeah. And you're going to put a question mark like you wasn't sure, Lisa. Okay.
Because I wasn't sure about the trade school part.
Yeah, it is. It is. You got it all correct. Some cases it's called vocational. So I don't know if you can see my document here. Lisa also helped us out with, our starting information for how to solve this problem. You want to make sure you copy this over, and we still got to clean this up, right? Because it's not Q0, it's Q0, and the 0 drops down with subscripting. All right, so we need also, I think I put this in the chat already for Ms. Moore, the 2 problems we're working on. Now we got to read through some things because we didn't start our agenda off right? You take this. I'm missing something else, something called the title. So while I'm cleaning this up, in the chat, who can tell me what is today's title? You'll be able to find it if you know where to look. And where to look is EDSB. Who can tell me what today's title is? Please type it in. Lisa racking up. Y'all, you need to catch up. Nobody knows. So if you go on EDSB, the name of the do now is the title. So who knows what it is? Nobody? Okay, let me resize screens and tell you what it is then. That was opportunity to get some points. So it looks like it's called Force Field Review, right? So let's type that in our title. It's called Force Field, and then it's a review day. So we did this problem, I think, last Tuesday. And it also has the classroom term in there that you need to solve the problem. So that term is, let me go back to EDSB because it's always the one in brackets, right? Just leave that alone. And then it's electric force is the classroom term there, if you didn't notice that. So there's a way to get 25 extra points in this class. And that's by making sure you have the definitions of electric force and the word of the day, which is the word of the day for the entire school. So the word of the day is, I'll put it in here so you'll know, apprehension. Okay? And should be is. There we go. And the term of the day, as I told you before, the classroom term of the day is electric force, right? That's what I'm looking at in EDSB as the term that I put there. You see it there in brackets, electric force. Okay, so far so good. You guys should have this much typed up with me because, if you at least take care of the definitions for here and here, this is a definition you need to find. You can use Google to figure it out, but make sure you use something that's physics based. And then the definition of what? For apprehension. You just give one definition. If you have the both of these, this will give you an extra 25 points that is used towards prior score. So consider this an exit slip, and it's worth 25 extra points. That's if you have those definitions. Now, the only student that I saw actually doing this well was a few, like Gabriel sometimes, and Lisa's done it a lot. Take advantage of that. That can help out in the long run, especially if you just need points to boost your score up a little bit. All right, now electric charge, right? We talked about this: electric force, electric field, the force of the electric force, the amount of charge that's given. Okay, now these values are pretty much going to be given in the problem as well. Okay, so let's go through it slowly, and then we're going to look at our simulation. Q naught. Got to edit this. These are notes from last week, by the way, thanks to Lisa Brown. The text, and then we're going to drop that down. That's how it should look on your screen. So all I did is I went to format. I'll do it again. Text and subscript. So that's a subscripted value. This is a subscripted value. And before you ask, do I got to do it that way? Yes, you do if you want full credit. Got to get quality work to get quality credit. Okay, so what else are we working with? Well, looks like we edited everything. I'll space this out a little bit because there's two ways to think about this. This is electric field. E is equal to F, which is the force on positive charge, divided by the amount charge Q naught. That's the equation we used last time. But now, when we do the problem, you're going to see we have to find F. So some algebra is done here. Let's just go through the algebra steps because that's the only thing that's missing from this. We have basically the new equation E.
Can I ask you a question? Can I run to the bathroom real quick? Just real quick.
Yeah, go ahead. Come on back so you can get the rest of these notes. Equals, right? I'm just making it look like a mathematical equation real quick. F, which is the force, divided by Q naught. So I'm going to take Q naught from up here. Q naught underneath because that's where it belongs. Okay. So that's in essence what we have, but now we have to solve for F, if you didn't notice that. And that's that last equation Lisa gave us. There's some algebra in between, and I don't want you getting confused. These are literally the same equations, but we did some algebra to solve for F. Now, what do you do to get F by itself? Well, if you're not aware, let's just change this format. You're going to pretty much take this entire fraction, and since it's being divided by Q naught, and you want F to be by itself, you multiply, because that's a division process where Q naught is in the bottom. So I'm going to put parentheses, and then take this Q naught and put it here. This will multiply the fraction out in a fashion that allow you to cancel out Q naught on that side of the equation. But you're not done because you have to remember what happens in algebra. What you do to one side, you have to do to the other. So just going to change the format a little bit. And then I'm going to come on this side, and I have to do it again, right? So I didn't want to copy that. I want to copy this one over here, and this belongs here actually. Now we have a new situation. Let me see if I can zoom in some more because I don't know if you guys can see it well. By the way, if you're looking at this screen, you want to hit the pin. It's like a little thumbtack. It'll let you zoom in some more because there's only so far I can zoom in for you guys. So I'm going to do 14, and that gives you a clear vision of what's happening algebraically there. Okay, so you should have this much typed up with me. Because, I mean, I'm giving you all the notes. And next Friday, I want to see some improved scores. I don't want to have too many bad scores going out for progress reports. So take good notes. I mean, all I'm asking you is take notes and use them for the quiz. I'm literally doing all the math for you guys. Okay, so what cancels out now, right? We should all know this by now. Okay, so only thing I see is the Q naught is over Q naught on this side of the equation. So pretty much this cancels out, right? This is Q dot divided by Q naught. And this part cancels out as well, which leaves an entire new equation. Well, the one we see at the bottom, right? If you can see it very well. So that is going to be what? Where F, because all this is gone now, is equal to this. So let's rewrite it the way you see it below. Take this F and put it on the other side. And this, just writing it from left to right like we do in math. So that's how we have this equation here. All right. Now, what we want to do next is, and this is basically the E field should be by itself, like electric force is equal to Q naught amount of charge divided by, that's the same equation, multiplied by the E field. Here we go. So let's keep going. Let's space out these two problems. Now, I'll let you know, where's the rest of the problem? Oh, it didn't come over from the chat. Okay. So hold on. It's right here in Edsby. Where did it miss? So I want you to have both problems. You're responsible for both of these problems. So force field, it's right here somewhere, right? Has, there we go. And the please remember part I didn't need. So I'm just putting the rest of the second problem in there. All right, cool. This doesn't go. That's just from the earlier thing. And we didn't even talk about that. But for the sake of time, and we didn't do the simulation, we're going to come back to at the end for participation points. We're going to read that out. But let's get into our simulation part. You should have this much typed up is what I was trying to tell you guys. Okay. These parts, the definitions, you have to fill those in. And if you have them in, that'll count 25 extra points into your overall score for today and previous assignments. So it'll help. I mean, if you do exceptionally well on this report and you don't need anything outside of the 100%, it can go somewhere else. So you can stack your points basically, right? So you should have this much set up in your Google Doc, because next we're about to plug in our simulation for today. So what time is it? No, I cannot give y'all a break yet. It is now 12:44. We got here 1:20, so we got to push through. So we can calculate these out, because there's two of them we have to calculate in this problem. It's a part A and a part B, and I'm gonna get you through A, start you on B, but you got to do it all over again for your practice problem at home. Okay, so let's get into it. Did the simulation work for most of you? Because I'm about to switch to that. If you do not have the simulation, let me know. It's basically this screen. So this is a battery resistor circuit. And in this circuit, you have charges like we've discussed, right? These are the Q naughts. Now the force comes in the form of this battery here. Okay, it has a potential amount. The resistance is what slows down the current. So you need to turn on all of these values. You show the core. If I turn the core off, you don't see what's happening with the resistor. If I turn off the voltage, you won't know exactly how much voltage is being calculated. You saw the electrons and the other ones, they went away, right? So here's it again. How many electrons, how many negative electrons, and how many volts? There's a calculation. So we're at 0.72. So all this should be showing. And then you can even change the resistance, which we're going to talk about a lot next week when we talk about circuits, or the voltage. So the voltage can be highly negative. You see a battery flip, or it can be highly positive, depending on how much voltage you give it. Notice these carriers. They take the electron only in the battery part, and that's a nice way of explaining how voltage takes a potential from the beginning to the end. Okay? So how do we make the battery hot? This is what I want to ask somebody in the chat or anyone. If you have it up, how can we make this battery, or not this battery, but this temperature here, which is the resistor, turn hot? What do we do? Any ideas? And you can use the settings for the voltage, the resistance, but I want to see what could you do to make it turn hot? Who can tell me? Are you saying something, Gabriel, or are you dancing? What are you doing?
Make the voltage go all the way up. maybe.
Okay,
Nigga,
Lisa, I'm gonna stop sharing, and I want you to share your screen. And do you have it up already?
Yeah, but I have it on halfway. But okay.
Okay, can you start it from low and then go to high? Let's see what she has. Okay, she's presenting. Okay, you got it going. Oh wait, yeah, you got it hot. Okay, your screen is a little bit shrunk though, but
I don't know why.
uh, you probably got to hit refresh or something.
Okay.
Hit the refresh, and I know you're gonna start your settings over, but it's only always gonna resize it better. There you go. It should, because it's a graphics resolution thing underneath. Yep, graphics system is initialized and it does that. Okay, now take us slowly through what you did. Then we're gonna do a print screen. Good. Now, how did you do that? Great. And how do we turn it from cold to hot? Notice that this meter is for the resistance. The resistor on there is getting hotter and hotter as she increases the voltage. The reason for this is because she hasn't changed the resistance. Now, if she lightened the resistance, it might cool off. Yeah.
So lower it.
Yeah. So you can control it. And this is what happens in your households. You ever had a lightning storm? Too much electricity flies through the circuits and then you catch fire. Okay. Well, great job, Lisa. You can stop sharing.
Okay.
Now, the next part is we take a snapshot. You have to have your simulation set up the way mine is. All right. What I want you to do is take a
Mr.
snapshot.
Tyler,
Yes.
can you go back on yours and show me one more time?
Yes. I'm about to share right now. So I want you to take a snapshot of your resistance hitting the middle between cold and hot. So you got to change it like Lisa did, right? Did everybody see what I'm doing? And you want to make sure you change it to a point where it turns more towards hot, but not exactly hot. You want to catch it right when it's in the middle. So mine's is there. And then once it hits the middle, you press print screen. Make sure you press it right then and there like I did. And if I come over here to my document, I can now hold control and press V. Now, what is control V? That's another shortcut, right? You come to edit, it says to paste, you hold control and press V. So now I got to edit my document. This is the last step of this, and then we're going to do the problem. You click on your document in Google Docs. I hope everybody's following this because they're like, why I got all this other stuff? Because you don't know how to crop your picture. So you click on your picture, make sure it has outline of blue, right? And then click on crop image. And then it has this black border around it. I'm going to grab one side of the border. I'm going to come over. And then that side is pretty much gone. It's visible, but it's really gone. I'm going to take this side. I'm going to crop that out. So as much as you can. This way, people don't see too much of your desktop and what you really got going on as far as all your tabs. Okay, once you got it sized the way you want, where you only have your simulation, you come outside that box area and click once. Is it once or twice? Oh, there it goes. There's a lag. Okay, so now I have the image I want, and only the image I want. I can resize it. Now I'm ready to continue doing my problem. So it is 12:50. Let's see how much time we got.
How do you print screen it again? Because I see the print screen button.
All right, so you press the print screen button, right? Once you catch it right in the middle, okay?
Okay.
And then what you do is you come to your document and you paste it, Lisa. So you can either press Control V or you can press Edit and go to your paste.
Okay, thank you.
All right, so let's continue on because we want to knock this problem out and leave you guys some time to get ready for next period. The next steps are based upon using this equation here. So I'm going to copy this, and then I'm going to start setting up my known and unknown values for this problem. So what do I know about this problem? And then what do I not know? Anybody got an idea as to what your known values are here? Well, scroll up to the top and see the problem. Oh, the problem's down here. So let me take this problem and come up some. because it's supposed to be included with the notes. Okay, and then I'll put this problem here because that's where we started. There we go. So what do we have in the problem? We got, it says an electric field. That's E, right? That's 4.6 times 10 to the 4th power newtons per coulombs. So let me grab that. That's your E. I'm talking about the E we talked about in the equation that we just worked out. So we're going to say E is equivalent to this number here. What else do we know? Well, they give us, it goes in the positive direction, and they also give us the magnitude of the charge, right? So magnitude direction of the force this field exerts on a charge is 2.8, and it's microcoulombs. But we got to find the force, which is F. And that's why we did all these steps to solve for F. So I'm going to take this one because this is our part A value. So it's that plus 2.8 microcoulombs. And I showed you guys last week what you have to use for micro. It's a symbol. So put that here. And this is our Q naught, by the way, in case you forgot. This part of the equation.
Hey, sorry to interrupt. While he's doing that, guys, if you don't got your camera on, can you please turn it on? Thanks.
Please follow what the man is saying. Thanks for that, Mr.
I can't have my camera on and do the thing.
It's cool. You just checked in. I understand you're on the phone, right?
Yeah, I'm on my phone, so I'm
Okay.
like switching back and forth.
It's okay. You just got to check in every now and then so I can see it.
Yeah, thanks.
Okay.
What up?
Who's yelling? Who's that? Oh, Christian?
Yeah, what's going on?
Nothing's going on, sir. Are you keeping up with us?
Trying to.
Okay, that's good.
Yeah.
Okay. I got to remember that's your name because I'm slowing down now because I got to make sure I put his name in.
Yeah, it's all good. I've just been using my sister's Chromebook for a minute.
Oh, that's your sister's. Okay, I didn't know because the name pop shows up. I'm like, who is this?
Yeah.
Give me 1 second. I'll make sure I fix the attendance real quick. See, Kyra's having computer issues, if I remember. Franklin, I don't see. Davis, nope. Connor, nope. Latrell is not here. Carter, he's been here. Lisa's been here. Okay, let me refresh and make sure this saves everybody before we continue. You can kind of see what's happening with the problem. So Joel just made it. Is that who it is? Okay, yeah, Joel just arrived. All right.
Well, my computer be tweaking. I'm blue.
Oh man, you gotta get better with it, man. I'm gonna tell you. But the document and that we're working on is the problem. Can someone, Lisa, can you put the link for the simulation back in the chat for him? Melody's not here, Jamel's not here, Alexis not here, and Wallace is not here.
Yeah, I'll try. I
Thank
just
you.
joined back.
Oh, you just came back. Dang. All right, I'll put it.
Somebody unplugged my computer.
Oh, man, wow. You have some struggles. All right, let me put the link in here so Joel will have it. And it should work on your phone too, sir. So, but you just got to make the simulation we made. I'm going to scroll up in a second, show you what that simulation looks like. So, this is the simulation. You got to recreate it. And it looks like this on a bigger scale. So, but when you have time, just take a snapshot of it, put it in your document. I don't know. You got your computer going yet, or is it down? Okay, it's not replying. All right, well, let's finish the problem off. So, because I'm looking at the clock, we have our snapshot of what happens, an application of charge being manipulated through a battery system with a resistor. And we went on to what we had in the problem. Now, this is our part A portion for a given. And you have a part B. So let me put that note in there. So part A is asking you for what happens when you have this amount of charge. And I was explaining how you have to word micro in terms of coulomb. So we take this and come down because we have to convert that. And micro is actually this Greek symbol. So we come to insert and special characters. And inside of special characters, you have to type, make sure you select math, but you type micro and it'll give you the character. It's populating. There it is. So I type micro and you'll see this symbol, which is also known as mu, right? So click that, and you click it once, it pops up with microcoulombs. Now you're like wondering, what is micro? Well, micro is basically 10. 1 second, I'm going to show you a spread note. The -6, right? Let's come up here. And if you ever wonder what I'm talking about, micro is a definition, right? So I should have put prefix because that's a different way. But micro is basically 10 to the 6th power. So prefix, there we go. Yep. So you see it's 10 to the -6. And I'm just going to put this in the chat so you guys will know, because I'm asking what kilo is, micro, milli, things like that. That is when you're using micro. So we're going to convert that down so we can calculate it. You definitely want to make a note of that so you don't forget on the quiz that's coming up. We're going to put 10 and it's raised to the -6. So I got to raise this -6 by using superscript. And it looks better. And this is times 10 because it's micro. So that's what you'll use. And you do subsequently, you do the same thing for part A. So let's just knock out part A so you're not looking at me all crazy like, what the heck? Copy this. And this is your part A value, part B value, I'm sorry. And that uses a different type of micro. Uses -9.3. Okay, so I'm gonna take that from here. That's the part B of the question. Right there. And again, you got to change it again, right? So we got to say all this jazz. That also means these two, but with the 9.3 in there, or negative. So this is negative, right? And then we can get this 9.3 and put it in, or -9.3, because that was in our part B value. And also here. Okay, so that's in essence the conversion for part B. Now, unknown. What is unknown? What do we have to find in both fields? Well, we have to find the F, which we did the algebra for, the electric force vector for part A and part B. So known, unknown is, what is the force when you calculate for part A? Be in newtons, right? Or is it Newton? It's Newton coulombs. I'm sorry. Yep. Yeah, Newton coulombs. I want to be sure. Newton. I want to make sure that conversion goes out for you guys in the next part. And then what is the part B? Well, it's the same thing. What is the force amount in the second step, or the second part of the problem? B. Okay. All right, let's keep going. Now we should have this much typed up. I'm going to come back and do a share out. So Gabriel, are you there? I'm looking at straight hallway. Is this another Easter egg? Lisa, goodness gracious. So Gabriel, are you there? I mean, it could be if you look at it the right way, Lisa. Okay, he's not there yet. Daje, are you there? This is just me checking on you guys, make sure
Yeah,
you following
I'm
along.
on my other phone.
I'm here.
Okay, Richardson, thank you. Joel, are you there? Okay, oh, I see a hand. Okay, he's there. He's keeping up.
Yeah,
Oh,
my thing's just muted.
okay, I see, Mr. Okay, you can't play video games right now, Christian. You got to be working, man. Oh goodness. All right, thank you, Joel. So I think everybody's on point. Lee, are you there? I didn't see him. Okay. Lee is like not responding. All right. So look, let's knock out the problem, and then we can open up for questions about grades and how we're going to do this for tomorrow. All right. So you should have this much. I stopped here to make sure you had this much. Make sure I had your attention. But this much should be typed up. Okay. You got to go in Google Docs and make sure it's typed up, because at 8 p.m. today, let's go through this real quick. Let's use, for example, who can I use? Let's use Mr. Carter, for example. If I go to Mr. Carter in class, and all of you guys can do this for yourselves. Progress reports are coming up. I can see all of his classes, and then I can go to my class, and if you guys want to see what you're doing, you click on my work. So you got to understand, like, he's improving greatly, see, because Carter used to have a lot of these bubbles down here, but he's pushing them up. Now, that's one view that just tells you how you're doing in this class. Another view is your assessments. All right, now this has a list of all the stuff you still need to do, especially if it has a 0 by it. Go back and finish that. Okay, today's assessment is going to be here, and if it's 2 of them, because it's coming up real soon, where you'll see 2 assessments, and it's to help you guys out, will be upcoming assignments. But take care of anything you see do. Like this one is doing 7 hours. I wanted to make that make that known to you guys, because if I receive it late, it'll be yellow. If it's on time, you notice it doesn't have a receive late clip on it. Who's just coming in the room now? I just got a notification someone's coming into the room and it's not showing yet. All right, so I just wanted to talk about that briefly. But the calculation to finish this off, because it's 1:03, and I do want to leave you guys some time to get ready for your next period. Did somebody come in? Okay, it's not showing yet. We're going to put this into this equation, right? So we're going to finish calculating everything out. And how do we do that? We use this equation here. That's what we use when we calculated it down to force only. So that's going to be this here, and I'm bring it over, because we're going to now put values inside of it. So for part A, right, part A, we're at the finish line with this, everybody. You're going to type in what? Well, we're going to take this equation and we're going to type in the values from above. So part A, our Q naught was pretty much that 2.8 microcoulombs, right? So we're going to take this inside of Q naught down here. Okay. So that's one part. Then we have E, which is the magnitude of the electric field. Be this 4.6, and I should have cleaned that up. It's supposed to be raised to the power of 4, right? Raise it. Here we go. And then I'm just going to put this E inside of my E down here for the magnitude of electric force. This E. Okay, just copy and paste and try to teach you guys tricks on how to get the document done faster. Now, what's going to happen is this coulombs and newtons per coulombs, you see here that the coulombs in both of them, one's upstairs on the numerator, one's downstairs in the denominator. So that means one of these will cancel out. All right, it'll just leave newtons. So I'm going to strike out the coulombs because they divide out to make 1. All right. And yes, you have to have it set up the same way to get full credit. And what's left is newtons, as you can see. So let's rewrite it and then calculate it. And set you up with the very next one that you're going to do on your own. But don't forget, you have a homework problem to reinforce what we just went through. You do not need to make the simulation for the homework problem, but you need to do at least try it and do it. So I'm going to delete this part because now we just have newtons. And these coulombs are gone too. So now we have a new calculation that we can just use Symbolab for. So let's see what that becomes in this last iteration. So if I go to Symbolab, just pop a tab open here, and we type SYMBO, a Symbolab. Grab it and put it in the chat so you can have it and use it on Friday's quizzes. All right, Symbolab. And now with that, we're just going to plug in these values. Now do it slowly because you can type something wrong, get the wrong answer. And yes, I'm very sharp on that. I'm very, as y'all say, petty. So parentheses, right? Just type as I type 2.80 multiplied. I'm using my keyboard, or you can use a digital keyboard on your your phone or whatever you're using. 2.8 times 10, and then we're going to raise it to a power. So I'm going to click on this raise x raised to something, and it gives me a box that's a superscript, and it's -6 here, right? That's why you got to take your time. Press the direction key out of the parentheses. And this is going to be multiplied by parentheses again, 4.60, and then times 10. We're going to use that, raise it up to the power part, and it's 4. From that point on, you hit enter. Let's see what calculation we get. The decimal value. All right, so it's going to be about 0.13. So where's the document at? It's right here, actually. So the force is going to be 0, which is not a lot because it's a very, very small point charge. So it's going to be 0. This part is a duplicate. So 0.13 newtons. All right, that's in the part A. We still got to go back and do part B real fast. So I'm just going to copy and paste some notes that you'll need to finish it. And it's going to be up to you to finish that, and also your homework problem, your asynchronous problem. Okay, so that's the final part of part A, but what about part B? One thing changes in part B is what? Our Q naught, right? Go through and change your Q naught and redo your calculation. So I just took what was in part A and duplicated it, because it's pretty much the same, but the only thing that changes, like I said, is this part right here. It's plus 2.80. So I'm going to take that out, and I'm going to replace it with what we have for our Q naught in part B. And that's that -9.30. So I'm just going to go ahead and clean it up for you guys. And it's going to be up to you to use SimLab to get the final answer to this, but don't think you're done. You still got to go back and with a little practice, figure out what it is going to be for your asynchronous problems. You got to do all the steps. You're literally just doing all the steps. It's just practice. When that quiz comes, you're not all looking at it crazy. The answer here is not going to be this. It's going to be something else, because now you have a negative 9.30 in there. Recalculate it using SimLab. All right, so it's 109. We effectively get out of here at 120. Do you guys have any questions for me? Do you need me to scroll up? Somebody want to take a snapshot? I don't know, but you are still supposed to calculate part B and both parts A and B and the asynchronous problem, the homework problem. So it's 0.13 newtons as well, Lisa? For the other part?
No, I typed it up before you answered.
Oh, goodness gracious. All right, my bad. I see it on the
I
time
know
frame. You did a minute.
it's the same problem last week.
Okay, you got the credit. I was like, who said that? Because I was like, that's what I typed. Good job. So, any questions, anybody? I think I talked to you about everything. It's recording in case you want to go back and, do it slower. Or you was on your phone and you couldn't type. This video will be available around 4:30, I want to say. And it'll be in the library section in YouTube format, as well as a downloadable MP4. Okay, so one at a time, I just wanted people to share out their screens. If you have something on your screen, you're free to go. So who's going to go first? What can you share? What have you done so far?
I got it. I'll do mine first.
Go ahead, Carter. Let me stop sharing. Guys, don't forget about those word of the day and classroom terms of the day. That's 25 points you can get. Don't let it slip through your fingers. All right, so I think Carter's going first, but I don't see his screen yet. Unless you're working on it. Okay, good. This is good, dude. You was keeping up. All right, okay. Well, I'll see you tomorrow. Turn that in, Carter. 8 p.m. All right, who's next? It's that simple. You got to have something done. This is called in-class demonstration points. I had to start using that to make sure people were doing what they had to do. Gabriel left without showing. Okay. Lisa, okay. All right, Lisa, did you get your simulation picture in there? Okay. All right. I'm just checking. See you later, Miss Brown. Thanks for all your help.
Bro, I joined late and
8
I've been
p.m.
confused.
What did you say, Joel?
I said I joined late and I've been confused for the last. I don't know how long I've been in here, bro.
Mr. Tyler.
Okay. Well, Joel, you can try to get it
Wait,
done. Give me one second.
wait, was I late enough to be counted as absent or I'm late?
Late, not absent.
Okay.
So just get the work done.
Mr. Tyler.
You missed more. Go ahead.
I can only flip my camera.
Oh, you trying to show your work? You've
Yeah.
been getting it down on that phone, little girl. Okay. All right. So try to get your image and everything later. I don't know how you're gonna do it. Can you get by a
Okay,
computer at all?
I'm gonna just have Lisa text me and help me.
Okay, that'll work. You try to get it in tonight.
Okay.
Ms. Richardson, do you have anything to share? Can you share your screen, Ms. Richardson? I think she's muted. Oh, there she goes. Were you saying something?
Can you hear me?
I can hear you now. Yeah.
I said I'm gonna try to do it now.
Okay.
Okay.
Okay. So she's gonna try to knock it out now. Christian, are you working on it or what you got going, dude? Okay. Make sure this attendance is logged right.
Miss Tyler, I can't do it, but I can screenshot it and send it to you.
You say you can't share your screen?
No.
Okay. All right.
Because I'm
So
on this stupid phone.
it's okay. Don't get frustrated. You try it. So do what you can and try to submit what you can on ESB, okay?
Okay.
All right. I'll see you later. I want you to relax for your next period.
Okay. See you.
All right. Christian, are you there? Mr. Fuentes, are you there? He got the camera off.
Tyler,
Yeah.
everything good?
So far, so good. I'm trying to get Christian back on the line, but it's all right.
Okay.
Oh, there he is. Dude,
What's going on?
you tell me, was you able to get anything done?
Yeah, my bad. I just got the family with me right now.
Oh, okay. You gotta try to turn in something tonight, man.
Can you put that down, please? Thank you. What was that? I'm sorry.
So try to type up that report. Check out the video. See how to do it.
All right.
Okay, turn it in by 8.
All
right.
Sounds good.
Okay, you free to go, man.
All right. Bye.
Goodness gracious. Oh Lord.